Welcome to 1.8 Parallel Lines and Proofs. In this lesson, we're going to be talking about parallel lines, transversal lines, and 3 new types of special angles. So before we get into that, let's talk about two types of lines that don't intersect. So the first type are skew lines. They're not in the same plane and they don't intersect. Also, they're not parallel. One thing to note is that they are non-coplanar, which is just a fancy word to say not in the same plane. What does that mean? Well, here's one plane, and let's say a line is within that plane. And here's a separate plane, and there's another line. You can see that they are not parallel, and they're not in the same plane, and they will never intersect because they're in different planes, okay? So that are skew lines. Those are skew lines. Now parallel lines, these don't intersect, but they are coplanar. That means they lie in the same plane. So down here, this is an example of parallel lines. They're in the same plane, they'll never intersect. Now how do you indicate parallel lines? Remember, when we wanted to show congruency, we used hash marks. But what do we do for parallel lines? We use arrows. Just like that. Now, how would you represent that in writing? Well, you would say line AB and 2 straight lines and line CD. So this states that line AB is parallel to line CD. One way to remember this is that parallel has 2 L's, and these look like 2 L's, and they also look like a pair of parallel lines. Okay? Now, in 1.8, we're going to focus on parallel lines. And what is the significance of parallel lines? Well, if we have a transversal line, so a transversal, it's a line, ray, or segment that intersects coplanar lines, rays, or segments, and the significance is that this creates special pairs of angles. So why do we care about parallel lines? Because if a transversal line intersects this pair of parallel lines, we will get 3 new special pairs of angles. And I have written them right here, so let's go over them. First, let's go over corresponding angles. So I'm going to tell you that this angle, let's call it 1, and this angle, let's call it 2. These 2 are corresponding angles. Why? Because they are on the same side of the transversal. So here's our transversal, and they're both on the right side. They could both be on the left side as well. But in this case, the one I drew, they're on the right side. And they're on the same side of each parallel line, right? So here's one parallel line, and this is on top. Here's the other parallel line, and this angle is on top. So they're both on top of their respective parallel lines. And most importantly, they're congruent. Why is this important? Later, we will use these special pairs of angles and their relationships to sort of determine missing angles, the measure of missing angles, okay? And can you identify all the corresponding angles? You can go ahead and pause the video to identify more corresponding angles. Okay, if you pause the video, we can talk about more corresponding angles. So this green would count as 1. Here's another set of corresponding angles. These are both on the right side of the transversal, and they're both below their parallel lines, okay? What is another pair of corresponding angles? Well, up here, 5 and 6. They're both on the left side of the transversal, and they're both on top of their parallel lines. And finally, 7, 8. You can see that 7 and 8 are corresponding angles because they're both on the left of the transversal and on the bottom. So you can see it can be on the right or left, up or down. As long as they are the same, it means they're congruent. And how can you remember this? Well, a way to remember this is that corresponding means to have a similarity. And that makes sense because they're on the same side, they're on the same side of the parallel line and the transversal. So that is their similarity, therefore these are corresponding angles. Okay, so let's get into the second type, alternate interior angles. So I'm going to tell you that this and these pairs of angles are alternate interior angles. Well, for one, they're inside the parallel lines, so that would be any angle in here. Could be this one, this one, this one, or this one. And they are on opposite sides of the transversal. So this angle here is on the right side of the transversal, and this one is on the left side of the transversal. And what is the significance? Again, they are congruent. Okay, so those two are congruent and they are a pair of alternate interior angles. And these two are congruent because they are a pair of alternate interior angles, okay? Now let's get into the third one. Consecutive interior angles. Same thing. They're on the inside of the parallel lines, so that would be in here. But this time, they're on the same side of the transversal. So this, angle 1, angle 2, these are consecutive interior angles. What is the significance? They are supplementary. Maybe you might not see this now, but as we get into the proofs and the postulates, you can see why that is. Okay, so 1 and 2, those are a pair of consecutive interior angles. And 3 and 4, these are consecutive interior angles. How can you remember this? Interior means inside. Consecutive, this basically means follows one after the other, right? So 1, what's the next angle that follows? Right here, right? Because remember, for corresponding angles, if we wanted to find the corresponding angle for angle 2, it would be this one. We'll say 5. 2 and 5 are corresponding, right? They're not consecutive because you're skipping this angle. However, angle 1 and 2 are consecutive because they come right after each other. And it's not because of their numbers, okay? If this one was angle 7, and this was angle 2, they're still consecutive because this angle, if you move down the transversal, here's the next angle. So they follow each other. Okay, same thing here. If you look at this angle, now move down the transversal, there is another angle that follows. If you're unsure about the word consecutive, an example would be 1, 2, 3, 4. This is the order of numbers, right? When you're counting, and these numbers you would say they're consecutive because they follow each other, one after the other, okay? And for this one, alternate interior angles, let me just draw them again. A way to remember this is that interior means inside, alternate, you can think of taking turns, flipping back and forth. For example, let's say you had a striped shirt, and it was blue, white, blue, white, blue, white. So it just alternates and it goes one way and then the other. And that kind of makes sense because these angles are on opposite sides. Okay, so that's how you can try to remember it. Okay, and one thing important to note is that these two are congruent, but this one, the relationship is supplementary, okay? And that makes sense because if you look at this, so these two are consecutive. It makes sense because this angle is acute, but this angle is obtuse, so there's no way they can be congruent if one is more than 90 degrees and one is less than 90 degrees, okay? So it makes sense that they are supplementary. So let's get into this postulate, the consecutive interior angles postulate. So this states that if two parallel lines are cut by a transversal, the consecutive interior angles are supplementary, okay? So this is a postulate and we can use it to help prove the corresponding angles theorem. So this states that if a transversal line cuts two parallel lines, then the corresponding angles are congruent. Remember, what are corresponding angles? Well, if we look up here, these are the ones that have a similarity and they are congruent. So that would be 2 and 6. So now let's try to prove that, okay? So what do we know for sure? We know that lines C and D and line E and F, they are parallel to each other and they are cut by a transversal line AB. What's another thing we know? We know that 1 and 3 are supplementary. Remember our linear pair lines? Angles. Linear pair angles were adjacent and supplementary. We know that from previous lessons, okay? So we can write let's say angle 1 plus angle 3 equals 180. And what else do we know? Well, we know that 3 and 5, these are our consecutive interior angles, right? Remember our postulate, consecutive interior angles. So that would be 3 and 5. They are supplementary. Okay? So these are things we do know based on the postulates and with what is already given. And now we can use what we know to prove the corresponding angle theorem. So just like we did before, angle 1 plus 3 equals 180, angle 3 plus 5 equals 180, and we can set it equal to each other, right? This is saying that this equals to 180. So why don't we take this expression and plug it into here instead of 180? So angle 1 plus angle 3, right? I'm just rewriting this, but instead of writing 180, I'm going to replace it with this. So angle 3 plus angle 5. And now you can see that if we subtract angle 3 on both sides, it will cancel out. So we end up with angle 1 equals to angle 5. And this proves that angle 1 and angle 5 are congruent because they are corresponding angles. And the same thing for angle 2 and 6, because they're on the same side of the transversal and they're on the same side of each parallel line. So this was how we proved the corresponding angles theorem. But more importantly, you should recognize these three special pairs of angles and how they relate to each other and how you can use it to solve for missing angles.